Okay, this video tutorial is a continuation from the first one. Be sure you watch the first one before this one. Okay, as per the security policy of the organization, the chat need to be configured on the PPP link, right? You want to know whether the PPP link is completing all the phases required to complete both the chat authentication and the circuit connection with Cisco debug command to troubleshoot the problem. You want to know whether the PPP link is completing all the phases, so you need to use debug PPP negotiation. Uh, you run the show running config command on the local router and ask your colleague at the remote location to send you the output. The partial configuration of both the router is shown below. Okay. Here is the problem. The username, you have to use the remote, and the password, this has to be the same. Okay. So this username has to use the remote and the password has to be the same. So the problem is the password are incorrectly defined in both router. The host name, the username is incorrectly the username is incorrectly in the local router and the password is incorrectly defined in both router. Okay. There. Which two statements are true regarding the partial output in the show IPBGP summary, right? Show IPBGP summary. This one, the local autonomous system. The local WAN autonomous system is 20,000, and then they are running version 4, and the neighbor is 191. Okay, and it has been up for 40 seconds. All right, don't get confused with the version 3. So this is actually version 4. So the answer is the remote supposed to be so the remote autonomous system number is 10,000, and the two router have received from the neighbor. The partial configuration of R1 and R2 is shown in the exhibit. How to fix the problem? Okay, here if you notice that router BGB 1000, but here the remote dimension is 10,000. So this has to be changed. Okay. So the command of BGP router BGB 10,000, and then you put the network that you want to advertise. 81 network, 82 network. Okay, the neighbor, this refer to the remote one. Remote which is 20,000 is correct, but this one neighbor 191 remote 10,000 is wrong. So you need to change that. So you need to change the router to BGP, change the autonomous system, change the autonomous system of R2, right? R2. Remove the network. Change the autonomous system on R1, yeah. Well, R1. No, oh yeah, no, here. Here has R2 has to be changed to, or this one. So change the autonomous system number on R1. This one you need to change it to what? No. This is not autonomous number. You shouldn't change that R2. This one's supposed to be what? Change the network comment? Network comment? No. This has to be Okay, hold on. Let me pause this one. Okay, here is the autonomous system is 1000. So you need to change this autonomous system remote autonomous on R1. You need to change the autonomous system to 1000. Okay, hold on. The neighbor is the neighbor remote. You should not change the network statement. Neighbor 191 remote 1000. Okay, here that you need to change this one. On R1, you need to change neighbor 191 remote as 1000 correspond with this R2. Okay, so what they mean is you change that one. Because on R2, because in okay, the BGP, the router BGP is 1000 on R2, so this one on R1 remote as autonomous system, you need to change this to 1000 to be consistent with that. That's what it means by that. Which metro Ethernet service is full mesh? Full mesh is ELAN. ELAN. E-line is ELAN, local area network. E-line is point to point. E3 is point to multi-point. Which protocol provides tunnel establishment and interface? Dynamic multi-point protocol is next hop router protocol. They also use dynamic routing protocol and HRP. Okay. What is the name of the router that an ISP connect to the customer site and form the edge of a tunnel in MPLS? What is the name of the router that ISP used to connect to the customer site? That's called provider edge. If you are in the consumer, you're going to use consumer edge. Which class of service allow you to carry up to 8 different level priority? 8021P is 8 different level, but DHCP is 64. So the answer is 8021P. Which two things should you verify on the GRE? Well, you need to know the valid tunnel source and the destination. You need to have that. Okay. Here is the sample configuration. Interface tunnel 0. This is the IP address of the physical 10.1.1.1, and the tunnel mode is GRE IP. Tunnel source is FA00, and this is the tunnel destination 191. You notice that the GRE used TCP port 179. Okay. IPsec is usually not required, but they use enhance the security and authentication when combined with GRE. Router 1 and 2 have been configured using GRE. The EIGRP neighbor are down. What causing the problem? Okay. Don't get confused with too much information. If you notice that the tunnel source is 111, the destination is this one, the fast Ethernet, which is the remote. Here is the tunnel source is 112, and the destination, notice that it's supposed to be this one. Supposed to be, this is the source, and the destination supposed to be 192 here. So here is 111 here, and this one's supposed to be 1111. So the problem is there. It looks like so difficult, but the GRE tunnel misconfiguration, right? On R1. No, this is correct, but this is the problem is here, the destination. So is GRE tunnel misconfiguration on R2, because this R2, the tunnel source is 11112, but the destination is supposed to be this one, 1111.